Alright guys, so this is going to be the review, so use this as needed. You can fast forward all around this video if you'd like. Whatever you need to do, but just pause it and practice. I mean, use this as a practice. So first one, 4 balls of wool will make 8 knitted caps. That's obviously our fake ratio. This is going to be learning target number 1, ratio tables. How many balls of wool will Malcolm need if he wants to make 6 caps? Okay, so we're trying to figure this out. So we've obviously got a scale to right there. So we've got to figure out a number that we can scale to. So the first one that came to my mind was 2 because they're both even. So we know that we would be dividing our number of caps by 4 there, so we've got to divide by 4 there. We've got to multiply by 3 there, so we've got to multiply by 3 there. That's how we get 3. Okay, now you could also have used a multiple, a common multiple. In this case would be 24 times 3 times 3 divided by 4, we still get 3. Okay, we could also use, well, we could use 1 in this case, but let's not. Let's just stick with the GCF or the LCM. Okay, so that's the first one. Okay. Okay. In a computer lab, there are tables and chairs only. Okay. The ratio of tables to total furniture is 4 to 9. So we do our edge pieces obviously first. Some of you still are refusing to do these. I'm not sure why, but you should always do them. So that is, we know that that means there are 4 tables. We know that there is 9 total, right? Which, if there's 9 total and 4 of them are tables, then it remains the remaining ones, 5, are chairs. Okay, so I'll do number 1 right here. So I'm going to do my proportion. Remember our steps. Step 1, proportion. Step 2, labels. Step 3, fake ratio. Step 4, real. And then finally step 5 would be to solve it using cross, multiply, divide. So we go, if there are 36 total, since I see total, we know that totals always go on the bottom. Okay, and then we're looking for chairs. So we know we're doing chairs to total. And yes, total has to be on the bottom because totals always go in the bottom. Done with step number 1 and 2. Now we're on to the fake. I get this ratio right here. I get all the information for this from my edge pieces up here. Okay, that's all fake information. And I know the fake ratio is 5 to 9. And the real piece of information they gave me was that there was 36 total. So we know that we are going to cross multiply and divide by 9, and we are going to get 20. Okay, that's number 1. Number 2, again, we're going to follow the same steps. We're going to do a ratio first, or I mean a proportion first. Now we're going to do labels. It said if there are this many chairs, then how many tables? So we know we're doing chairs to tables. Chairs to tables. Make sure you do TA for tables, since both total and tables start with the letter T. Okay, what is the ratio of tables, or I'm sorry, chairs to tables would be 5 to 4, and the real information they gave me was 30. Okay, from here we can cross multiply and divide. We would learn that the answer is indeed 24. 24 tables. Okay, all right, so that's one of those. That's learning target 5 and 6 there. Okay, one of these, we've done a bunch of these, so we'll do another one now. Okay, below is a recipe to make fruit salad that serves 32 people. How much of each ingredient would you need to serve 24 people? So we have to, once again, use scaling like we did on that previous question. You're going to have one just like this on the summative. So again, if you want to just try it right now, might not be a bad idea to try it and come back to it. Okay, we have to figure out a number that 32 can become, and that same number can also become 24 using multiplication and division only. So we know that it either can be the GCF or the LCM, or just a CF or a CM. So if you actually want to, you could go over and do your trees for all of these, figure out the GCF. I will tell you the GCF for 32 and 24 is 8. So then we're looking at this going, okay, what are we doing to our number of people served? Well, we're dividing them by 4. If we divided the number of people by 4, then we've got to do the same thing to all of our ingredients. 8 divided by 4 is 2. 16 divided by 4 is 4. 12 divided by 4 is 3. Now we're going to go on to answer the question. So what are we doing to go from 8 to 24 times 3? So we've got to do that to all these ingredients here. Be 6, 12, and 9. Okay? All right. Okay, we'll do one of these. Mr. Garrison's truck can travel at a speed of 240 miles in 3 hours. How far can it should say my truck, but regardless, you guys understand that. How far can the truck travel in 8 hours? The key here is use unit rate to solve. This is learning target number 7. You're going to have one of these on the summative. Okay, so we do this. We do our first proportion, which is use unit rate. So we've got to find unit rate. Now we need to figure out whether it's going to be miles and then hours on the bottom or hours and then miles on the bottom. That's what we need to figure out. We look to our real information. How far can the truck travel in 8 hours? Well, since it gives us a real amount of hours, then we want to figure out the amount of miles I'm traveling per hour. Per hour. So nothing changes with our little 4-step process. Proportion, labels. Now we're going to put our fake ratio on there. Now you could either cross multiply divide or just know that, okay, I'm dividing my number of hours by 3. So that means I need to divide my number of miles by 3. That teaches me that it's going to be 80 miles per hour. Okay. Now we're going to use that unit rate right here, the unit rate, as our fake ratio. So we're going to bring it right over. And then what piece of real information did they give us ultimately? 8 hours. So we're going to put 8 right there. Remember, a proportion is 2 equivalent ratios. So as long as you have 3 of the spots filled, you can solve a proportion. So we see that we're multiplying our number of hours by 8. So that means we need to multiply our number of miles by 8, which gives us 640 miles. All right. This one I'm going to do what it's saying. I'm only going to do a couple of these. Okay. Now you're more than welcome to practice with these other ones if you'd like, but I'm not going to do them on this video. I'm going to do letter B, but I got to do the first part first. So we're talking about plums and pears. So I am right now just going to go ahead and get rid of kiwis and oranges. I'm only going to focus on this. So the first step is we have to find the unit price. We have to figure that out. That's where we have to start. So we know finding unit price just means a proportion with money on top and whatever the object is on the bottom. So for this one, we'll do plums here. Notice they both start with P. So I'm going to do PL for plums. I know that my fake ratio is that 9 plums cost $2.43, and I want to know the cost for 1 plum. So I'm dividing by 9, Probably have to get your calculator out here for this. Obviously, you can use it on the test. Okay, so it's going to be 2.43 divided by 9. It's going to give us 27 cents. Notice I did this number first divided by 9. It has to go in that order. Some of you are doing 9 divided by 243. You can't do that. You can't flip the order in a division problem. It's this number divided by 9. Okay? So I know my unit price here is going to be 27 cents. Now we'll do our other proportion to figure out the unit price for pears. So I'll do PE for pears. Again, we know money's on top because it's unit price. Okay, and then it's going to be 93 cents for 3 pears. We want to know the cost of 1 pear. Divide by 3. Divide by 3. That's going to be 31 cents. So we'll bring that over, 0.31. Okay, so now I know the unit prices. That's the first part of the question. Now let's go and let's figure out how much it's going to cost for 12 plums and 5 pears. So I like to do this with proportions also. So what we're going to do is I'm going to do 2 different proportions. Once again, 1 for plums, 1 for pears. Plums, plums, PE for pears, PE for pears. Okay? Now, we know money's obviously going to go on top because we're talking about unit price, and that's how we did it up there in the top. Now, for our fake ratio here, guys, we are going to use not edge pieces or anything like that. This is where it gets a little bit different, but we're going to use these numbers here because we know if we know that 1 pear and 1 plum costs 27 cents, then it's pretty easy to set up. So what I'm going to do is I'm going to take my fake ratio, which is actually my unit price, and I'm going to do 27 cents per plum, and I know I need to buy 12 plums, then I can just simply say, okay, that's going to be times 12 times 12. Okay, and that's going to be 0.27 times 12 would give me $3.24. Over here, I know that my pears cost 31 cents a piece per one, and I want to buy 5 of them. So I'm going to do 31 cents times 5. It's going to give me $1.55. And then the last step that you have to do on this one is you are now going to add your two totals amount, because this is how much 12 pairs cost. This is how much, this is how much 12 plums cost. This is how much 5 pairs cost. We need to add those together. So once again, use your calculator. Plus 3.24, $3.24. We get $4.79. Okay. Biggest thing on unit price questions, any money questions. If I were dividing something and I got this in my calculator, we've got to remember that we've got to round to money. This right here is either going to be 25 cents or 26 cents. And it's all about what the number to the right is telling us. If this number is 5, 6, 7, 8, or 9, then it's going to go up one here. This one, 8 is definitely 5 or more, so this would be 26 cents. Whereas if I had this, 0.85854, we should know that's either 85 cents or it's 86 cents. We look to the number to the right. That number is not 5 or more, so therefore it's going to remain at 85 cents. Okay, rounding money. Okay, better buy question right here. We've done really well with these. A 16-ounce box at mac and cheese at Walmart costs $5.60. So I'll do Walmart over here. We'll do that one first. Follow our 4 steps. It's proportion, labels, fake, real. So we've done a proportion. Now we're going to do labels. We know it says which store is offering the better deal per ounce. So that tells us right now we're talking about 1 ounce. So ounces has to be on the bottom. Money on the top, we're talking about unit price. And we know this is going to be $5.60 for a 16-ounce box. We are going to divide by 16. Divide by 16. Again, making sure we put $5.60 first in our problem. So 5.60 divided by 16. Okay, that's going to give us 35 cents. Okay, that's Walmart. Now for Kroger over here, we'll do this in red. Okay, we do labels next. We're not going to change anything. We're going to keep it exactly the way we did with our Walmart example there. Only this one, they got a 20-ounce box for $6.20. We need to know the cost per one. So we're going to do $6.20 divided by 20. That's going to be 31 cents. So if you're looking at this, who's got the better buy? Clearly, it is Kroger, right? Because they are paying less money per ounce than at Walmart. Now, how much will you save? Well, that's where you just subtract them. 35 cents. 35 cents minus 31 cents would be 0.04 cents. Notice I put 0.04, not this. We don't use the cent sign. Okay. All right, we'll do 2 of these. This is learning target number 9. We've all done really well. Biggest thing is understanding that I expect you to use proportions on this. You have to use proportions. Okay, so if I were doing this one right here, I know that we're going to put our labels on next. So meters to kilometers, meters to kilometers. The fake ratio is in all the conversions. The fake ratios will all be given. So at the bottom, it's going to say, okay, there are 1,000 meters in 1 kilometer. That'll be given to you on the test. So we know that this would be 1,000 meters for every 1 kilometer. The real information is 25,000 meters. Okay. Now from here we can just cross multiply and divide. So I'm going to do 25,000 times 1 divided by 1,000, which is 25. Most of you could probably do that mentally, but you have to show the proportion. The fake ratios are these things right here. Okay? All right. This one, cans of corn, another scaling question. Cans of corn are on sale for 10 of them for $4. This is our fake ratio. We need to know what the cost is going to be for 15 cans. Well, we don't know what we're doing to go from 10 to 15. Like if this number was 20, it would be easy. Times 2 would make it $8. But there's nothing you can multiply, no whole number you can multiply 10 times to give you 15. So we have to scale. Now, once again, if you ever get stuck, you can go over, do your trees for 10, do your trees for 15, stack them up, 2 times 5, 3 times 5. They have a GCF of 5. That's the easiest way to start. Now, what am I doing to my number of cans? Dividing it by 2. So what do I got to do to my number of dollars? Divide by 2. What am I doing to go from 5 cans to 15? Times 3. So what do I got to do to my dollars? Times 3. $6. Now, if you want to use the LCM, you can always use the LCM as well. Okay, we know that we take the GCF 5 and we multiply by anything not circled, and that would give us 30 there. Times 3 there. So we got to do times 3 there. Divide by 2 there. So we've got to do divide by 2 there. Either way, you're getting 6. Okay, do this real quick. I'm going to do a couple of these if I can. This is going to be the last question on the summative. This is the one that people are really struggling with, but it's really not that hard if you just do it my way. The ratio is 18 boys for every 15 girls. Okay, so what I'm going to do is I'm just going to bring this down and I'm going to write it right here. 15 girls. Okay, if the gym teacher gets 4 boys and 4 girls added, so what I'm going to do is I'm just going to, if that happened, I'm going to put how many would be there. So we know it's going to be 22 boys and it's going to be 19 girls. Here's my 2 ratios. Now think back. We just have to know if the new ratio is going to be the same as the original ratio. Remember the big 3 methods? I'll write them for you if you don't remember. It was cross products. Okay, that's where you multiply diagonally. And if you get the same answer, then you're good. For instance, 2/4, 2 to 4 and 1 to 2. If I cross products these, I get 4 either way I go. That tells me they're equivalent to one another. Here, 15 times 22, 19 times 18. I'm not going to do it, but you guys get the point. The second of the big 3 is you can simplify them, which is probably the best way for this. Okay, the third way is just to divide them. Okay, so if I simplified 18, if you did 18 ABC 15. Now, first of all, I want you to all understand it's going to give you a mixed number. Okay, it's going to give you 1 and 1/5, I think. Yes, it's going to give you 1 and 1/5. Now, it's your job then to turn it back into an improper. Oh, that means 6 to 5 around the barn. So that would mean 6 boys for every 5 girls. Or you could just say, okay, I know both these have a factor of 3, so just simplify it that way. Either way, you get 6 to 5. Now, 22 and 19, that's already in simplest form. There's no factor that they share. So clearly, are they the same? Are those the same? No, that would be false. It would not remain the same if those students were added. Okay, this question right here. Matt Hall takes basketball lessons from Sammy Brown every summer. He took 12 lessons and he paid $90. There's your fake ratio. Okay, at this rate, how much would it cost him to take 18 lessons? So what we have to do is we have to scale right there to right there. Okay, and we have to get a good spot where we can scale in there. Okay, once again, this number either has to be the GCF or the LCM. I think it's pretty easy to see that 6 works perfectly. I'm dividing my number of lessons by 2, so I divide my number of dollars spent by 2, 45. Now I'm multiplying my number of lessons by 3, so I've got to do the same thing here. Either way, it's 135. Okay, if you're doing this and you're checking yourself right now, and maybe you scaled to something else, maybe you scaled to 2, it's fine. Divide 6, that's fine. You'll get a decimal, that's okay. Okay, you could have also went to 3. Divide 4, you would also get a decimal there. It's okay. You could also use the LCM, which is 36 times 3 times 3. Either one of those is fine, but really the GCF is the one we're trying to get you to use. Okay, this question here, I had a little bit of an issue with it on the formative. It's okay, we're going to talk about it right now. The cost of 5 tickets to the Olentangy versus Olentangy Oranges is $20. Okay, we need to complete the table to figure out how much it's going to cost for 1 ticket, 2 tickets, and 4 tickets. So the way I'd really want you to do it, really the easiest way here is just to add a little row. Add a row down here. Okay, and if you put 5 there, Then you're just looking at it going, okay, so there's my fake ratio. What am I doing to go from 5 tickets to 1? Dividing by 5. What am I doing here then? It'd be 4. 20 divided by 5 is 4. Now, if you didn't want to do it that way, then you could go over and say, you know what, I like proportions. Mr. Garrison's made me use proportions, so I just want to keep on using proportions. Fine. No problem at all. Okay? I know we're trying to figure out per 1 ticket, so that means tickets on the bottom. Unit price, or the price is going to go on top, which means unit price. My fake ratio is right here. Okay? So that's going to be $20 for 5 tickets. I'm dividing by 5, dividing by 5. That tells me that each ticket is costing $4, which means if I double my tickets and go from 1 to 2, that's $8. From 1 to 4 would be times 4. So we do 4 times 4 would be 16. Okay? Now, the ordered pair, well, if this is your x and this is your y, and it's x comma y, then you just do that comma that. 1 comma 4. That is a 1. This would be 2 comma 8. This would be 4 comma 16. Okay? Now, you won't have to graph it on the summative this time. Okay? You won't have to graph it, but you are going to have to answer that question right there. Describe the pattern in the graph. So, let's bring this up. Oops, I didn't want to cover it up. It's so easy here, guys. I mean, I'm telling you the answer. It's going to be constant. It has to be constant. And the reason why is because if I graph these, it'd be over 1 up 4. Then it would be 2, 8, which is just over 1 up 4, over 1 up 4, over 1 up 4, over 1 up 4. Every time we go up here, because that 1 ticket, these are your tickets down here, your dollars are here. Every time we add 1 ticket, we go up $4. So it's going to be a straight line. It has to be a constant rate. If it's a ratio table that it has equivalent ratios, then it has to be equivalent to one another. Everybody got that? Okay. All right, modeling question. Okay, we'll do one of these real quick. I have several blue and gold marbles in a bag. The ratio of gold to blue is 8 to 3. Okay, so obviously we should do edge pieces real quick. Okay, so I'm going to do my edge pieces right here. Ratio of blue to gold is 8 to 3, so that means 8 blue, that means 3 gold, which means 11 total, right? Here we go. If there are 88 blue marbles, then how many gold marbles are there? So I'm going to do my work for this one up here. So proportion first, then labels. It gave me blue. It asks for gold. So I do blue to gold, blue to gold. My fake ratio says blue to gold is 8 to 3. My real information was that 88 of them were blue. If you cross multiply and divide there, you're going to get 33 gold. Okay. Number 2, if we did a proportion there, you can see that it's giving me gold. It's asking for total. So we're doing gold to total, gold to total. My fake ratio of gold to total was 3 to 11, and the real information was 36 gold times 12, or cross multiply divide. That is going to be 11 times 12 is going to give me 132. Okay? All right, now I'm going to go down and we're going to do a modeling one here. Okay? The model below shows the ratio of boys to girls is as 7 to 4. Okay, so as you can see, I got 1, 2, 3, 4, 5, 6, 7 of those right now. That's why, because there's 7 boys for every 4 girls. Just wrote the fake ratio. If we want to do edge pieces, that'd be fine. That would be 7 boys, 4 girls, 11 total. Okay? It says, if there are, there's your real information, if there are 121 total students, how many of them are boys? So we're using the model on this one. Okay? So if we're using the model, remember, the whole goal to every single model we've ever done is to figure out what one of these little rectangles are. We've got to figure out what one little piece is. So you could do, this is just a unit rate, okay? But you're either going to be doing 121 divided by 7, 121 divided by 4, or 121 divided by 11. Now think about it. Is the 121, is that representing these 7, these 4, or all 11 of them? Hopefully you're saying all 11 of them. Okay, so we're going to do 121 divided by 11, which is going to give us 11, which puts 11 of these in each one of these boxes. Now we just have to answer whatever the question's asking. It wants to know how many boys there are. Okay. Well, if we have 11 in each box and there are 7 boxes, that means 77 boys. And if we just want to figure out the girls just because, then we have 11. We have 4 groups of 11. That's going to be 44 girls. Okay. Modeling, the biggest thing is right here. Trying to figure out what that number that's given is representing. Is it representing the boys, the girls, or the total? That's what you need to figure out. Okay, here we go. We'll use the model here. This is basketball players. This is football players. You can try this one on your own. Okay, we will do number 1 first. It says if there are 42 basketball players. So basketball is these 3. So that means this right here, these 3 boxes, equals 42 basketball players. So remember, what's the whole goal to a bar model? Figure out how many is in one, right? Figure out how much is in one of those. So again, here we go with that same thing. Is it going to be 42 divided by 3? 42 divided by 8? 42 divided by 11? What's it going to be? And in this case, it is going to be 42 divided by 11. Or, I'm sorry, by 3. Which is going to give us 14 each. So now, we know that there's 14 players represented in each one of these groups. And then so on. I could write in all those. We need to answer the question, how many of them are going to be football players? So we're going to do, to figure that out, we would do 14 times the 8 groups we see there, and that would be our answer. So whatever 14 times 8 is, 112. Okay? So the models, like I said, it's all about asking yourself, does that represent just a part of it, the other part of it, or all of them? That's what you really need to figure out. You can try these, but I'm not going to go over the answers. A proportion is 2 equivalent ratios. A unit rate, just look for the word 1, really. I mean, it's the amount of something per one of something. It's a ratio when you have one of the terms as being compared to 1. That's all it is. And then a rate is a comparison of 2 things with different measures, different units. Okay, we've done a bunch of those, I think. Another better buy question you can try if you'd like. You can try any of these, really. I mean, you can try them. I'm just not going to go over them. There's one where you got to use unit rate. It should say learning target 7. Mr. Zinker's truck. Okay, so that one's needs edited a little bit. Here we go. Using unit rate once again. There's another unit rate one. Here's another better buy one. Or not better buy, but unit price question you could try. Okay, let's do one more of these. There are 20 girls and 18 boys in band. There's our fake ratio. Now I'm just going to come down and I'm going to write it. 20 girls for 18 boys. Okay, if I were to add 4 boys, so I'm going to add 4 boys, that's going to put 22 boys in the class, and I'm going to add 2 girls. That's going to give me 22 girls. Is the ratio going to remain the same? So again, we use the big 3. You could use cross products. You could divide them, or you could simplify them, which I think is very easy now that you know how to simplify in your calculator. Now I'm just going to simplify them by hand. I know that both of these 2 numbers have a factor of 2. So if I divide both the top and the bottom by 2, that's going to give me a ratio of 10 girls for every 9 boys. This one over here is going to give me 1 girl for every 1 boy. So are they the same ratio? No, clearly not. This one down here, 24 girls for 18 boys. Now I'm going to add 4 boys. Whoops. I'm going to add 4 boys, which is going to give me 22 boys. And if I add 3 girls, that's going to give me 27 girls. Right? Let's simplify them, divide them, cross product them, whatever you got to do. I'm just going to simplify them. When I simplify 24 to 18, I know that they both have a factor of 6, so I would be dividing by 6 to both top and bottom. That would give me the ratio of 4 to 3. Right? Over here, you would find out this would not simplify. That is done. So that's the simplified ratio for that one. That's the new one. Are they the same? Clearly, no. They're not the same. They are not the same. Now, on the summative, they could be the same. You need to work that out. Okay? There's another one there that you could try. That's if you'd like. And it's right there. I'll try to be able to explain it. If I were to do that one real quick, it would be 12 girls for 16 boys. That's the original ratio. Now we're adding 6 girls, so that's going to put 18 girls in there. And it's going to put 24 boys in there, right? I'm adding 8 boys. Okay, let's simplify them. I simplify this. I know that I can divide both the top and bottom by 4. That's going to give me 3 girls for every 4 boys. I know the GCF of 18 and 24 is 6, so I'm going to divide by 6 to both these. That's going to give me the new ratio of 3 girls for 4 boys. So right there, do they have the same simplified ratio? Yes, they do. So this is an exact example of when it is yes. So it's not always no. I want to make sure you guys understand that. Okay?